AP Calculus, section 7.3, page 7. Today we're going to start looking at non-circular cross sections, which means when we cut this thing up, this three-dimensional figure, we are not going to get circles or washers or shells anymore. We have other shapes. So sometimes a three-dimensional figure is sliced up and the slices or elements of area are not circles. Think of a pyramid with a square base. If we slice parallel to the base, so here's your pyramid, square base, we get slices that are squares. Slices that are squares. Here's another example of something that you might see. Oh, there's your pyramid almost. It's just offset a little bit here. And can you see all those squares put together? Or maybe if I turn it this way. You see these all squares here? When you slice this up, you would not get circles, you would get squares. Okay, we're going to start off looking at some examples here. Find the volume of the resulting solid. The solid that lies between planes perpendicular to the x-axis at x equals -1 and at x equals 1. So x equals -1, x equals 1 right here between these planes. Cross sections perpendicular to the x-axis, so I'm cutting through this way, and I am going to go ahead and put that cross section in here. Perpendicular to the x-axis, and when we slice perpendicular to the x-axis, we get cross sections oh, there's a lot of different ones we're going to do in here today. So we have this top piece here, this bottom piece here, and when we cross the section through, we are going to get a circle. The cross section is a circle. How do you find the area of a circle? Pi r squared, where here's the radius. This one's kind of similar, but we're going to work through it. When we look at this then, to find the volume, we are going to need to add up a bunch of circles times thickness. All right, when I look at the way I'm slicing through, that thickness is a dx, and the area of a circle is pi r squared. All right, now what's the radius here? The radius is this distance, the radius of that circle sitting this way. That's y, that's the y value to that top parabola up there. So radius is y squared times dx, but we can't have y's in here, we have to have x's, so let's flip that. That y was this distance to, so we have the square root of 1 minus x squared squared. How convenient is that? Okay, bounds now. Start slicing to stop slicing. We're out here at -1 to 1 x values. So we started slicing at -1, went all the way up to +1. So we could slice from -1 up to +1, or could we slice from 0 to 1 and then just double it? That works for me. Okay, working through this then, we have 2 pi. If we anti-differentiate here, that's going to give us x minus 1/3 x cubed, evaluated from 0 to 1. That's going to be 2 pi. Let's plug in a 1, so we have 1 minus 1/3 minus 0. And 1 minus 1/3 is 2/3. So we have 4 pi over 3 as that volume. Okay, yes, this one looks very familiar. Yes, we could have done this with discs and discs because we're ending up with circle slices. The next one won't be that way. I wanted to do something that was kind of familiar first, and then now we're going to move on to some squares and triangles as slices on the next page.